Okay, to conclude this very brief introduction to the summary for policymakers from Working Group 2 of the IPCC under Assessment Report 6, focused on impacts, adaptation, and vulnerability. We'll close with examples of regional key risks. So here, absence of risk diagrams does not imply absence of risks within a region. The development of synthetic diagrams for small islands, Asia, and Central and South America was limited due to the paucity of adequately downscaled climate projections. So most of the IPCC models do global projections. There was a program called CORDEX, coordinated downscaling experiments, which produced some regional information, downscaling from the IPCC projections. There have been issues about whether that degrades the IPCC global solutions in a region like the monsoon, where the ocean coupling is very important, and CORDEX often is done, I think almost always is done with forced atmosphere model regionally. So they are taking sea surface temperatures from IPCC global models and forcing regional models, and produces lots of useful information but can be tricky. Nonetheless, not everywhere is such downscaled information available, so that's one of the problems. With uncertainty in the direction of change and diversity of climatologies and socioeconomic contexts across countries within a region, and the resulting few numbers of impact and risk predictions for different warming levels, the development of synthetic diagram was not done for all regions. Okay, so just keep in mind. The risks listed are of at least medium confidence level. So everything is medium or above. Lack of information and low confidence are not presented at all. So they are looking at small islands, North America, Europe, Central and South Asia, and few more regions like Australasia, Asia and Africa, as we already said before. So various aspects: loss of terrestrial, marine and coastal biodiversity and ecosystem services, loss of lives and assets, risk to food security and economic disruptions due to destruction of settlements and infrastructure. In North America, the issues are climate-sensitive mental health outcomes, human mortality and morbidity due to increasing average temperature, weather and climate extremes, and compound climate hazards, which we have discussed elsewhere. I'm just reading a couple, for example, for illustrating. In Europe, it's about risks to people, economies and infrastructures due to coastal and inland flooding, stress and mortality to people due to increasing temperatures and heat extremes, etc. And Central and South America looks at risk to water security, severe health effects due to increasing epidemics, in particular vector-borne diseases. Australasia has issues in degradation of tropical shallow coral reefs and associated biodiversity ecosystem service values, loss of human and natural systems in low-lying coastal areas due to sea level rise. Okay, as I'm just reading the top two in each case. For Asia, urban infrastructure damage and impacts on human well-being and health due to flooding, especially in coastal cities and settlements, biodiversity loss and habitat shifts, as well as associated disruptions in dependent human systems across freshwater, land, and ocean ecosystems. Okay, those are the top ones. For Africa, it is species extinction and reduction or irreversible loss of ecosystems and their services, including freshwater, land, and ocean ecosystems. Secondly, risks to food security, risk of malnutrition, for example, micronutrient deficiency, and loss of livelihood due to reduced food production from crops, livestock, and fisheries. So similar diagrams as we saw before with global surface temperature change with respect to the base period, and looking at the various issues that we mentioned. Here is Africa, Mediterranean regions, Europe, and looking at food production from crops, fisheries, and livestock in Africa. So as soon as we cross 1.5 degree warming, with medium confidence, we can say the risk is going to increase to very severe very quickly. Biodiversity and ecosystems in Africa, similar. Mortality and morbidity from heat and infectious diseases in Africa. Delayed impacts of sea level rise in the Mediterranean hits fairly hard very quickly when you cross 1.5 degrees, and we have already we're already very close by 2021 in this case. Okay, water quality and availability in the Mediterranean, health and well-being in the Mediterranean, water scarcity to people in southeastern Europe. You can see that we are already in the low to medium risks based on the warming we have already experienced, and very quickly we're going to get into high and very high risks. Coastal flooding to people and infrastructure in Europe, risks from those, and again you can see that this has a little bit more room here above 1.5, but by 2 degrees you're going to again hit very high risks. Heat stress, mortality and morbidity to people in Europe can be low and medium risk up to 2 degrees, but beyond that it begins to get high and very high risks. I'm just going to go through those, but you need to stare at these figures carefully based on the region you come from and based on the sector that's of interest. Loss and degradation of coral reefs in Australia. Look at this. We are already in danger. Great Barrier Reef is suffering already, and we are already at very high risk, and this is with very high confidence here. So we are basically going to wipe them out if we reach beyond 1.5 and 2 degrees centigrade. Of course, we have talked about issues such as coral reefs in some other regions responding well to warming, and whether there are ways in which corals could be grown in lab or genetically grafted to make these more resilient to heat and so on. So there are great efforts going on to see what can be done. Okay, also including geoengineering approaches like brightening the clouds over the Great Barrier Reef to reduce the incoming solar radiation impact and so on and so forth. Cascading impacts on cities and settlements in Australasia, again already in the high risk situation, going to very high very quickly once we hit beyond 1.5 to 2 degrees C warming by 2100 with 66% probability. Actually these are from model projections, so we don't even have to worry about 66% probability. These are already what are possible under various scenarios, and so we have to worry about actually when we will hit 1.5 or 2 degrees C. Doesn't say exactly how long we have to stay above these thresholds for these risks to kick in, but we don't want to experiment with that, right? Reduced viability of tourism related activities in North America has some room till 2 degrees C, but then it begins to get into high and very high risks. Costs and damages related to maintenance and reconstruction of transportation infrastructure in North America. We have some time to keep the risks low. Lyme disease in North America under incomplete adaptation scenario. Again, it's already there, almost endemic, so the risk is going to get larger beyond 2 degrees centigrade. Sea ice ecosystems from sea ice change in the Arctic. We are already in danger, in very high risk. By 2 degrees C, it's going to be quite not at all a good scenario in terms of sea ice ecosystems. Changes in fisheries catch for pollock and Pacific cod in the Arctic. We can tolerate up to 2 degrees C, but very quickly we're going to go into medium and very high risks. Costs and losses for key infrastructure in the Arctic. Again, some room there to still make some difference with adaptation and mitigation. Sea ice dependent ecosystems in the Antarctic. Again, you can see it's a little bit better than the Arctic in terms of the room left till 1.5 degrees C. There are lots of differences in the Antarctic in terms of, for example, polar amplification, because Southern Ocean makes a difference as opposed to the land ice albedo feedbacks, water vapor cloud feedbacks in the Arctic versus how the Antarctic behaves. Changes in krill fisheries in Antarctic, again, by 2 degrees C, it's going to be high to very high risk, and this is going to affect large ecosystem dependent on the krill fisheries, like the whales and so on. Okay, so diverse feasible climate responses and adaptation options exist to respond to representative key risks of climate change with varying synergies with mitigation. Here, multidimensional feasibility and synergies with mitigation of climate responses and adaptation options relevant in the near term at global scale and up to 1.5 degrees C global warming are looked at. Obviously, I'm not going to read the whole table because it's a lot of information here. So you can see that land, ocean ecosystems, climate responses and adaptation options are looked at, urban and infrastructure systems, energy systems, coral, cross-sectoral issues, for example, health and health systems adaptation, livelihood diversification, planned relocation and resettlement of human migration, and so on. And we are looking here at observed correlation with sectors and groups at risk. So ecosystems and their services, ethnic groups, gender equity issues, low income groups, and so on. So there is various details here with benefits, with disbenefits or negative impacts, not clear or mixed in many cases, insufficient evidences in several cases like ethnic groups and biodiversity management and ecosystem connectivity, as well as gender equity, for example. Confidence levels in type of relation with sectors and groups at risk are again shown with high, medium, and low. Here are the relations with sustainable development goals that we briefly looked at, which cover these areas here. No poverty, zero hunger, good health and well-being, quality education, gender equality, and so on. Okay, so you can see that there are relations with benefits and co-benefits or negative impacts. So you have to always be careful when you are doing something in terms of climate responses and adaptation options that are actually going to make the sustainable development goals worse in terms of where we want to go with those. Okay, so there are many such situations here which have negative impacts, but most are positive, which is good news. So this can be very tricky in terms of how to optimize the climate actions to make sure that sustainable development goals are also met. Finally, there is rapidly narrowing window of opportunity to enable climate resilient development, which is addressed in many ways in many reports. So this is looking at societal choices about adaptations, mitigation, and sustainable development made in arenas of engagement. This is illustrative development pathways, and these are actions and outcomes characterizing development pathways. So you can see here dimensions that enable actions towards higher climate resilient development include ecosystem stewardship, knowledge diversity, inclusion, equity, and justice. The arrows go this way, but it doesn't matter. Arenas of engagement here include community, social, cultural, political, ecological, knowledge and technology, economic and financial. Okay, again here arenas of engagement include the same thing, economic ecosystem degradation. So as opposed to stewardship, we are looking at how to the dimensions that result in actions towards lower climate resilient development. So these are beneficial, these are disbeneficial, as the word is used here. Singular knowledge, inequality and injustice, and exclusion. Okay, so past conditions such as emissions, climate change, and development in 2022 are here. And we are trying to go here towards 2030 Sustainable Development Goals, 2100 and beyond. So opportunities missed for higher climate resilient developments are noted here, with SDGs sitting here within a goal to be met at 2030. So you have present situation here, and you have various options related to warming to be kept below 1.5 degrees C. Adaptation enables sustainable development. So you get actions, outcomes characterizing development pathways to be higher here, and climate resilient development is in the medium here, and then lower here. So increasing warming path dependence and adaptation limits undermine sustainable development. So you don't want to go here at all. You want to stay here, but at least be here in terms of well-being, low poverty, ecosystem health, equity, justice, low global warming levels, and low risk. So sustainable development action, system transitions, transformation, mitigation, and adaptation happen here, whereas here vulnerability, high poverty, ecosystem degradation, inequity and injustice, high global warming levels with high risks. So unsustainable development action, entrenched systems, rising emissions and maladaptation. So these are the kind of things that are related to the shared socioeconomic pathways as well. So these angular lines like electric circuits are illustrative climatic or non-climatic shocks such as COVID-19, droughts or floods that disrupt the development pathways. So even if you're on a nice pathway, you might get a shock and you have to be able to recover and stay on path to your goals by 2100. Okay, so 2030 is right around the corner here, so obviously this is going to be quite a challenge despite the great progress on Paris Agreement, lots of commitments to net zero. One has to remember that we are still on emission pathways that are essentially business as usual. So this is something that's staring at us in the face in terms of reducing emissions, decarbonizing, and heading towards the net zero goals, even if they're out at 2050 for the US, 2060 for China, 2070 for India. Okay, so many of these pathways have to be set now in terms of all these actions in adaptation and mitigation, reducing risks and vulnerabilities and so on. Okay, let me stop here.